The Liebherr LTM 1750-9.1 crane represents a remarkable feat of engineering, standing as a testament to Liebherr's long-standing commitment to innovation and excellence in the field of heavy machinery. As an all-terrain mobile crane, the LTM 1750-9.1 is designed to provide unparalleled lifting capabilities combined with exceptional mobility, making it an indispensable tool for a wide range of industries, including construction, energy, and infrastructure. With a maximum lifting capacity of 750 tons and a boom length that can extend up to 52 meters, 170 feet, the LTM 1750-9.1 is engineered to handle some of the most demanding lifting tasks in the world. Its versatility is further enhanced by the ability to configure the crane with various boom and jib extensions, allowing it to adapt to the specific needs of each project. Whether it's lifting heavy prefabricated components for skyscrapers, installing massive wind turbines, or performing critical lifts in confined spaces, the LTM 1750-9.1 delivers performance and precision. One of the most notable features of the LTM 1750-9.1 is its 9-axle chassis, which not only provides a stable platform for lifting, but also ensures the crane can be easily transported to and from job sites. This mobility is crucial for projects that require quick setup and takedown, allowing the crane to be deployed efficiently across multiple locations. The crane's variable ballast system is another innovation that contributes to its stability and lifting power, enabling operators to adjust the counterweight distribution based on the specific requirements of each lift. The LTM 1750-9.1 is also equipped with Liebherr's advanced LICCON, Liebherr Computed Control System, which provides operators with real-time data and control over the crane's functions. This system enhances safety and efficiency by allowing operators to monitor the crane's load, stability, and other critical parameters during operation. The crane's Vario-based technology further adds to its safety features by automatically adjusting the outrigger support base to optimize stability, even on uneven terrain. In terms of applications, the LTM 1750-9.1 has been deployed in a wide range of industries. In the energy sector, for example, the crane is frequently used for the installation of wind turbines, where its lifting capacity and precision are crucial for handling large components in challenging conditions. In infrastructure projects, the crane's ability to lift heavy beams and prefabricated sections has made it a valuable asset in the construction of bridges, highways, and other large-scale developments. The assembly process of the Liebherr LTM 1750-9.1. The assembly of the Liebherr LTM 1750-9.1 is a complex and meticulously planned process that ensures the crane is ready to perform safely and effectively on the job site. This process begins long before the crane arrives at the project location, with detailed planning and logistics that are essential for a successful assembly. 1. Pre-assembly considerations. Before the assembly process begins, several preparatory steps must be taken to ensure everything is in place. This includes a thorough assessment of the site where the crane will be assembled and operated. The site must be evaluated for its ground conditions, space constraints, and any potential obstacles that could affect the crane's stability or operation. Logistics play a crucial role in the assembly process. The LTM 1750-9.1 is transported to the site in several components, each requiring specialized transport vehicles and careful coordination to ensure timely delivery. The transport of the crane's 9-axle chassis, boom sections, counterweights, and other components must be planned meticulously to avoid delays and ensure everything arrives in the correct order for assembly. Safety is a top priority during the pre-assembly phase. Before any work begins, a comprehensive safety plan is developed, outlining the procedures and protocols to be followed during the assembly. This includes safety briefings for all personnel involved, as well as the implementation of safety barriers, signage, and other measures to protect workers and equipment. 2. Base assembly. The assembly process begins with the setup of the crane's base, which involves deploying the outriggers and stabilizing the 9-axle chassis. This is a critical step, as the stability of the crane during operation depends on the proper setup of its base. The outriggers are extended and positioned on stable ground, ensuring the crane is level and secure. Once the outriggers are in place, the chassis is carefully positioned on the site. This involves precise alignment and leveling to ensure the crane's base is stable and ready to support the weight of the boom and counterweights. The use of hydraulic jacks and other leveling equipment is essential to achieving the correct positioning. 3. Boom and counterweight installation. With the base of the crane securely in place, the next step is the assembly of the main boom. The LTM 1750-9.1 feet S boom is telescopic, meaning it consists of multiple sections that can be extended to reach the desired length. The assembly process involves carefully aligning and connecting these sections, starting with the base section and working upwards. The installation of the counterweights is another crucial aspect of the assembly process. The LTM 1750-9.1 feet S variable ballast system allows the counterweights to be adjusted based on the specific lifting requirements of the project. The counterweights are carefully placed and secured to the chassis, ensuring the crane has the necessary stability and lifting capacity for the tasks ahead. 4. Installation of jib and auxiliary components. In some cases, the LTM 1750-9.1 may be configured with a jib to extend its reach or provide additional lifting capabilities. The installation of the jib involves attaching it to the main boom and securing it with specialized connectors and support structures. The process requires careful alignment and precision to ensure the jib is properly integrated with the crane's main structure. In addition to the jib, the installation of auxiliary components such as winches, hooks, and lifting gear is completed during this phase. These components are essential for the crane's operation and must be installed with the same level of care and precision as the main boom and counterweights. 5. Testing and calibration. Once the crane is fully assembled, a series of tests and calibrations are performed to ensure everything is functioning correctly. This includes load testing, where the crane lifts a test weight to verify its lifting capacity and stability. The crane's control systems, including the relocation system, are also calibrated to ensure accurate and reliable operation. During the testing phase, the crane's operators and technicians monitor the crane's performance closely, making any necessary adjustments to the assembly or calibration. This ensures that the crane is fully prepared for the lifting tasks it will perform on the project. Six. Final preparations and safety checks. Before the crane is put into operation, a final round of safety checks and inspections is conducted. This includes a thorough review of the assembly process, ensuring all components are securely in place and that the crane is ready for use. Any issues or concerns identified during the inspection are addressed immediately to prevent potential problems during operation. Operator training and briefing sessions are also conducted during this phase. The crane's operators are given detailed instructions on how to safely and effectively operate the LTM 1750-9.1, including the use of the relocation system and other control features. This ensures that the crane is operated by qualified personnel who are familiar with its capabilities and limitations. Operational considerations and best practices. Operating the Liebherr LTM 1750-9.1 requires a deep understanding of the crane's capabilities and the best practices for safe and efficient operation. This section covers the key considerations and guidelines for operating the crane, maintaining its performance, and ensuring its longevity. 1. Operating the Liebherr LTM 1750-9.1. The LTM 1750-9.1 is designed to handle a wide range of lifting tasks. But operating the crane requires careful planning and execution. Operators must be familiar with the crane's load charts, which provide detailed information on the crane's lifting capacity based on the boom length, jib configuration, and counterweight setup. Adhering to these load charts is essential for safe operation and avoiding overloading the crane. During operation, the crane's control systems play a crucial role in ensuring precision and safety. The LICCON system provides real-time data on the crane's load, boom angle, and stability, allowing operators to make informed decisions during lifts. Operators must also be aware of the crane's surroundings, including any obstacles, overhead power lines, or other hazards that could affect the lift. Common challenges faced during crane operation include wind, uneven terrain, and limited space. The LTM 1750-9.1 is equipped with features like Vario-based technology to address these challenges, but operators must remain vigilant and adjust their approach as needed to ensure safe operation. 2. Maintenance and service life. Regular maintenance is essential to keep the LTM 1750-9.1 in optimal condition and extend its service life. This includes routine inspections of the crane's components, lubrication of moving parts, and checking for signs of wear and tear. The crane's hydraulic systems, electrical components, and control systems must also be maintained and serviced regularly to prevent breakdowns and ensure reliable performance. Liebherr provides comprehensive support services for the LTM 1750-9.1, including access to spare parts, technical support, and training programs. By following a regular maintenance schedule and utilizing Liebherr's support services, operators can ensure the crane remains in top condition for many years. Three. Case studies and success stories. The LTM 1750-9.1 has been successfully deployed in numerous projects around the world, demonstrating its versatility and reliability. One notable case is the installation of a large wind turbine in a remote location, where the crane's lifting capacity and mobility were essential for completing the project on time and within budget. The crane's ability to navigate challenging terrain and perform precise lifts made it the ideal choice for this project. Another success story involves the construction of a major bridge, where the LTM 1750-9.1 was used to lift and position large prefabricated sections. The crane's stability and lifting power were critical in ensuring the safe and accurate placement of these sections, contributing to the overall success of the project. These case studies highlight the LTM 1750-9.1 feet-S capabilities and the impact it can have on a wide range of projects. By choosing the right crane for the job and following best practices for assembly, operation, and maintenance, project managers can achieve outstanding results with the LTM 1750-9.1. Ride and rigging of the Liebherr LTM 1750-9.1. The Liebherr LTM 1750-9.1 is not only a powerful lifting machine, but also a highly mobile one, designed to be transported easily to various job sites. Its ride characteristics and rigging capabilities are central to its efficiency and effectiveness. Is not only a powerful lifting machine, but also a highly mobile one, designed to be transported easily to various job sites. Are a result of its innovative design and rigging capabilities, are central to its efficiency and effectiveness. This chassis is engineered to distribute the characteristics of the evenly across its axles, reducing ground pressure and allowing the crane to traverse various terrains, particularly including nine-axle chassis or uneven ground. Is engineered to distribute the crane's weight evenly steering across its axles, which enhances maneuverability, reducing ground especially in tight or congested areas. To traverse various terrain is further supported by its compact dimensions or uneven transport mode. The chassis is also equipped with all-wheel steering, which enhances maneuverability, especially in tight or congested areas. The crane's mobility is further supported by its compact dimensions and counterweights when in transport multiple trucks for road transport. This modular approach allows the crane to be moved over long distances, broken down into even on roads with strict weight or size restrictions. One of the critical considerations when transporting the Liebherr onto multiple trucks for road transport. 1750. This modular approach allows the crane to be moved over long local regulations even regarding vehicle dimensions or size restrictions. The crane's design takes these regulations when transporting the Liebherr ensuring that it can be transported legally and safely on public roads. 9.1. Additionally, is compliance with local regulations regarding to provide a smooth ride during transport. The crane's design minimizing the risk of damage into the crane's components, ensuring that it can be transported legally at the job site, safely, ready for assembly and operation. Additionally, the crane's suspension system is designed to provide a smooth ride during transport, minimizing the risk of damage. Rigging process. Rigging is a crucial aspect of operating the Liebherr LTM 1750-9.1, as it involves preparing the crane for lifting operations by setting up its various components, such as the boom, jib, and counterweights. The rigging process begins with the assembly of the crane at the job site, which involves carefully positioning the chassis and extending the outriggers to provide a stable base. Once the chassis is in place, the next step is to assemble the crane's telescopic boom. The Liebherr LTM 1750-9.1 feet S boom is made up of multiple sections that can be extended or retracted depending on the lifting requirements. Assembling the boom requires precision and coordination, as each section must be carefully aligned and secured in place. The use of hydraulic systems in the crane's design allows for smooth and controlled extension of the boom, ensuring that it is properly configured for the task at hand. In addition to the boom, the crane may also be equipped with a jib to extend its reach or provide additional lifting capabilities. The installation of the jib involves attaching it to the main boom and securing it with specialized connectors and support structures. This process requires careful alignment and precision to ensure that the jib is properly integrated with the crane's main structure. Counterweights are another essential component of the rigging process, as they provide the crane with the necessary balance and stability during lifting operations. The Liebherr LTM 1750-9.1 feet S variable ballast system allows the counterweights to be adjusted based on the specific lifting requirements of the project. This flexibility ensures that the crane can maintain optimal stability and lifting power, even when handling heavy or awkward loads. Safety is a top priority during the rigging process, and all procedures are carried out in accordance with strict safety protocols. This includes conducting thorough inspections of all components, ensuring that they are in good condition and properly secured. Additionally, the crane's operators and riggers undergo extensive training to ensure that they are familiar with the rigging process and can carry it out safely and efficiently. Lifting projects involving the Liebherr LTM 1750-9.1. The Liebherr LTM 1750-9.1 has been deployed in a wide range of lifting projects, demonstrating its versatility and reliability across different industries. From the installation of wind turbines to the construction of industrial facilities and infrastructure, this crane has proven to be an invaluable tool for tackling complex lifting tasks. 1. Wind turbine installation. One of the most common applications of the Liebherr LTM 1750-9.1 is in the installation of wind turbines. These projects often take place in remote locations with challenging terrain, where the crane's mobility and lifting capacity are crucial for handling the large and heavy components of the turbines. Wind turbine installation typically involves lifting and positioning components such as the tower sections, nacelle, and rotor blades. Each of these components can weigh several tons and must be lifted to great heights with precision. The telescopic boom of the Liebherr LTM 1750-9.1, combined with its variable ballast system, allows the crane to perform these lifts with ease, even in difficult conditions. One of the key challenges in wind turbine installation is the need for precise positioning of the components. The crane's relocation control system plays a vital role in achieving this precision, providing operators with real-time data on the crane's load, boom angle, and stability. This information allows operators to make informed decisions during the lifting process, ensuring that the components are positioned accurately and safely. The Liebherr LTM 1750-9.1 feet S ability to navigate challenging terrain is also a significant advantage in wind turbine projects. The crane's 9-axle chassis and all-wheel steering allow it to move between different locations on the job site with relative ease, reducing the need for additional equipment or modifications to the site. This mobility, combined with the crane's lifting power, makes it an ideal choice for wind turbine installation, where efficiency and precision are critical to the success of the project. Two, industrial construction. In the industrial construction sector, the Liebherr LTM 1750-9.1 is often used for lifting and positioning large prefabricated sections of buildings or heavy machinery. These projects require a crane that can handle substantial loads while maintaining the precision needed for accurate placement. The crane's modular design allows it to be configured for various lifting tasks, whether it involves lifting heavy machinery onto elevated platforms or placing large sections of a building structure. The ability to adjust the boom length and counterweight configuration ensures that the crane can be optimized for the specific requirements of each lift, providing the necessary power and stability. One notable example of the Liebherr LTM 1750-9.1 feet S use in industrial construction is the assembly of large manufacturing facilities, where the crane is used to lift and position steel beams, concrete panels, and other structural components. These components are often prefabricated off-site and must be lifted into place with great precision to ensure that they align correctly with the rest of the structure. The crane's advanced control systems, including the relocation system, play a crucial role in these operations by providing operators with the data and control they need to execute lifts with accuracy. The crane's stability, ensured by its variable-based technology and variable ballast system, is also essential for maintaining safety during these lifts, particularly when working in confined spaces or at significant heights. Three, infrastructure projects. The Liebherr LTM 1750-9.1 has also made a significant impact in infrastructure projects, particularly in the construction of bridges, highways, and other large-scale developments. The crane's ability to lift heavy beams, girders, and prefabricated sections makes it an invaluable asset in these projects, where precision and lifting power are critical. One of the primary challenges in infrastructure projects is the need to lift and position large, heavy components in often difficult or constrained environments. The Liebherr LTM 1750-9.1 feet S versatility and power allow it to meet these challenges head-on, whether it involves lifting steel girders for a bridge or positioning large sections of a highway overpass. In bridge construction, for example, the crane's telescopic boom and high lifting capacity enable it to lift and position heavy bridge sections with precision. The crane's stability is also a crucial factor in these operations, as even a slight imbalance could result in a dangerous situation. The LTM 1750-9.1 feet S vario-based technology ensures that the crane remains stable during these lifts, even when working on uneven ground or in challenging conditions. The crane's role in infrastructure projects is further highlighted by its ability to work in confined spaces, such as urban areas where space is limited. The compact design of the Liebherr LTM 1750-9.1, combined with its maneuverability and flexibility in boom and counterweight configuration, makes it ideally suited for these environments. A specific case study of the Liebherr LTM 1750-9.1 feet S involvement in an infrastructure project might involve the construction of a new highway bridge. In this scenario, the crane would be used to lift and position large prefabricated sections of the bridge, including the main girders and deck panels. The crane's precision and lifting power would be critical in ensuring that these components are placed accurately and securely, contributing to the overall success of the project. Lifting bridges with the Liebherr LTM 1750-9.1. Lifting bridges is one of the most complex and challenging tasks that a crane like the Liebherr LTM 1750-9.1 can undertake. The process involves not only lifting heavy components, but also positioning them with extreme precision to ensure the structural integrity and safety of the bridge. This section will explore the unique challenges of bridge lifting, provide a detailed case study of a bridge lifting project, and discuss the technical considerations involved in such operations. 1. Challenges of bridge lifting. Bridge lifting presents several unique challenges that require careful planning, coordination, and execution. One of the primary challenges is the sheer weight and size of the components involved. Bridge sections, such as girders and deck panels, can weigh hundreds of tons and extend over significant lengths. Lifting these components requires a crane with substantial lifting capacity and precise control. Another challenge is the need for precise positioning of the bridge components. Unlike other lifting tasks where a small margin of error may be acceptable, bridge lifting requires the components to be positioned with extreme accuracy. This is essential to ensure that the bridge sections fit together correctly and that the overall structure is safe and stable. Environmental factors also play a significant role in bridge lifting operations. Wind, for example, can have a considerable impact on the stability of the crane and the components being lifted. The Liebherr LTM 1750-9.1 feet vario-based technology and variable ballast system help mitigate these challenges by providing the crane with the necessary stability and control, even in adverse conditions. Site conditions are another factor that must be considered during bridge lifting operations. The terrain around the bridge site may be uneven or unstable, requiring the crane to be positioned carefully to ensure stability. Additionally, the presence of water or other obstacles may complicate the lifting process, requiring the crane to be configured and operated in a way that accommodates these challenges. Two. Case study. Bridge lifting project. A detailed case study of a bridge lifting project involving the Liebherr LTM 1750-9.1 would highlight the crane's capabilities and the unique challenges of such operations. For example, consider a project involving the construction of a new highway bridge over a river. In this scenario, the Liebherr LTM 1750-9.1 would be tasked with lifting and positioning several large bridge girders, each weighing hundreds of tons and spanning significant lengths. The project would begin with careful planning and coordination to ensure that the crane is positioned correctly and that all components are ready for lifting. The first step in the lifting process would be to assemble the crane at the job site, including the extension of the boom and the configuration of the counterweights. The crane's LICCON control system would be used to monitor the crane's stability and load capacity throughout the process, ensuring that it is ready for the lift. Once the crane is fully assembled and configured, the lifting operations would begin. Each girder would be carefully lifted into place, with the crane's operators using the LICCON system to control the boom angle, lifting speed, and positioning. The crane's precision and stability would be critical in ensuring that the girders are positioned accurately and securely, with minimal risk of damage or misalignment. Throughout the project, the crane's advanced features, such as the vario-based technology and variable ballast system, would be used to maintain stability and control, even in challenging conditions. The crane's ability to navigate the site and position itself for each lift would also be crucial in ensuring the project's success. 3. Technical considerations. Bridge lifting operations require careful consideration of various technical factors, including load calculations, crane configuration, and safety protocols. One of the most critical technical considerations is the calculation of the crane's load capacity, which must take into account the weight of the bridge components, the boom length, and the angle of the lift. The Liebherr LTM 1750-9.1 feet SLICCON system plays a vital role in these calculations, providing operators with real-time data on the crane's load and stability. This data allows operators to make informed decisions during the lifting process, ensuring that the crane remains within its safe operating limits. Another important consideration is the configuration of the crane's boom and counterweights. The boom length and angle must be adjusted based on the specific requirements of the lift, while the counterweights must be configured to provide the necessary balance and stability. The Liebherr LTM 1750-9.1 feet S variable ballast system allows for precise adjustments to the counterweights, ensuring that the crane is properly configured for each lift. Safety is also a top priority in bridge lifting operations, and all procedures are carried out in accordance with strict safety protocols. This includes conducting thorough inspections of the crane and all components, ensuring that they are in good condition and properly secured. Additionally, the crane's operators and riggers undergo extensive training to ensure that they are familiar with the lifting process and can carry it out safely and efficiently. Relocation of the Liebherr LTM 1750-9.1. Relocating the Liebherr LTM 1750-9.1 from one job site to another is a complex process that involves careful planning, coordination, and execution. The crane's size and weight, combined with the need to transport it over long distances, present several logistical challenges that must be addressed to ensure a smooth and efficient relocation. 1. Transportation challenges. The transportation of the Liebherr LTM 1750-9.1 involves disassembling the crane into transportable components, each of which is loaded onto specialized transport vehicles. The main crane body, boom sections, and counterweights are typically transported on separate trucks, with the transport process carefully coordinated to ensure that all components arrive at the new job site in the correct order. One of the primary challenges in transporting the Liebherr LTM 1750-9.1 is compliance with local regulations regarding vehicle dimensions and weight. The crane's design takes these regulations into account, ensuring that it can be transported legally and safely on public roads. However, the transport process may still require special permits or escorts, particularly when transporting oversized components. The terrain and road conditions between job sites can also present challenges during transportation. The transport vehicles must be capable of navigating a variety of terrains, including steep inclines, narrow roads, and uneven surfaces. Additionally, the transportation route must be carefully planned to avoid obstacles such as low bridges, weight-restricted roads, or other potential hazards. 2. Assembly and disassembly process. The assembly and disassembly of the Liebherr LTM 1750-9.1 are critical steps in the relocation process. Disassembly begins with the removal of the counterweights, followed by the disconnection and removal of the boom sections. Each component is carefully disassembled and secured for transport, with all parts inspected to ensure they are in good condition. At the new job site, the assembly process begins with the positioning of the crane chassis and the extension of the outriggers to provide a stable base. The boom sections are then reassembled, with each section carefully aligned and secured in place. The counterweights are reinstalled, and the crane is configured for the specific requirements of the new job. The assembly process requires precision and coordination, as any misalignment or improper connection could compromise the crane's stability and safety. The Liebherr LTM 1750-9.1 feet S modular design and advanced control systems help streamline the assembly process, ensuring that the crane is ready for operation as quickly and efficiently as possible. Three. Best practices for relocation. Relocating the Liebherr LTM 1750-9.1 requires careful planning and coordination to ensure that the process is carried out smoothly and efficiently. One of the best practices for relocation is to conduct a thorough pre-relocation assessment, including an evaluation of the new job site, the transportation route, and any potential challenges or obstacles. The use of experienced operators and technicians is also critical to the success of the relocation process. These individuals have the knowledge and expertise needed to carry out the disassembly, transportation, and assembly processes safely and efficiently. Their experience also allows them to anticipate and address any potential issues that may arise during the relocation. Another best practice is to ensure that all necessary permits and approvals are obtained before the relocation begins. This includes any special permits required for transporting oversized components, as well as any site-specific approvals needed for the assembly and operation of the crane at the new job site. Conclusion. The Liebherr LTM 1750-9.1 is a powerful and versatile mobile crane that has proven its capabilities in a wide range of lifting projects across different industries. Its advanced features, including the variable-based technology, variable ballast system, and LICCON control system, make it an invaluable tool for tackling complex lifting tasks with precision and safety. Whether it's lifting heavy components in wind turbine installation, industrial construction, or infrastructure projects, the Liebherr LTM 1750-9.1 has demonstrated its ability to meet the demands of the job. Its mobility, lifting power, and advanced control systems make it a reliable choice for operators and contractors who need a crane that can handle even the most challenging tasks. Looking to the future, the Liebherr LTM 1750-9.1 represents the cutting edge of mobile crane technology. As the construction and infrastructure industries continue to evolve, the demand for powerful, efficient, and versatile cranes like the LTM 1750-9.1 is likely to grow. With ongoing advancements in crane technology, Liebherr is well positioned to continue leading the industry and pushing the boundaries of what is possible in lifting and construction projects.